In this example, we're going to graph the function f of x is equal to 4x to the third plus 10x squared minus 4x minus 10. Now this one is not factored, so it is easy to identify the degree and the leading coefficient. That will help us determine the end behavior. However, when we go to find the x-intercepts, it's going to take a little more work because we're going to have to find the zeros of this polynomial, which will require us to solve this equation. All right, so let's start by identifying the end behavior. So this is a third degree polynomial, so the degree is odd, which means the ends will go in opposite directions. And the leading coefficient is positive 4, which means this will be an increasing function, which means it will start low and end high. The next thing we want to do is find the y-intercepts. And remember, to do that, we're going to let x equal 0. So we're going to plug 0 in for x, and that will give us 4 times 0 to the third plus 10 times 0 squared minus 4 times 0 minus 10. And all these terms with a 0 in it are going to go away because you're multiplying something by 0, it's just 0. And 0 minus 10 is negative 10. So our y-intercept is 0, negative 10. So we have 1 point on the graph, and we know the end behavior. So now we need to figure out what's going on in the middle. All right, so now we're going to do our x-intercepts, which are our zeros. So we're going to take this function and set it equal to 0. So we have 4x to the third plus 10x squared minus 4x minus 10, and we're going to set that whole thing equal to 0. Now this is a method of factoring that we've actually already learned how to do when we learned how to factor trinomials. So this one has 4 terms. But if we look at this in groups and just look at these first 2 terms, they have 2x squared in common. And if I pull that out front, what times 2x squared will give me 4x squared? And the answer to that is 2x, because 2 times 2 is 4, and x squared times x is x to the third. And then what times 2x squared will give me positive 10x squared, and that is plus 5, because 5 times 2 is 10, and then you have your x squared. Now let's just look at these 2 terms. They have just a negative 2 in common, because this term doesn't have x in it. But watch what happens when I factor out the negative 2. Negative 2 times 2x will give me negative 4x. And negative 2 times positive 5 will give me negative 10. Another way to think about this is you're dividing. So negative 10 divided by negative 2 is positive 5. Now, if I think of this as 2 terms, they have 2x plus 5 in common. So I'm going to pull that out front, what they have in common, and then what's left over is 2x squared minus 2, and I'm going to set that equal to 0. So I've now factored that polynomial, and now I can use the zero product property to solve it. We have 2 things multiplied together to give us 0, so one of these has to be 0. So 2x plus 5 equals 0, or 2x squared minus 2 equals 0. So if I subtract 5 from both sides, that's going to give me 2x equals negative 5. And then if I divide both sides by 2, I'm going to get negative 5/2. There are several different ways you can solve this. I'm going to solve it by first factoring out that 2, and that will leave me with x squared minus 1, because that's 2x squared minus 2. Then if I divide both sides by 2, that's going to give me x squared minus 1. 0 divided by 2 is still 0. And these two canceled. So this is a difference of squares. So that can be factored as x plus 1 times x minus 1. And that's equal to 0. Now I can set each one of these equal to 0. So that's going to give me x equals negative 1 or x equals 1. So I have 3 zeros. X equals negative 5/2, x equals negative 1, x equals 1. Remember, these are also x-intercepts, so I can write them as ordered pairs. And we also need to know the multiplicity of each one, or how many times they were zeros. Well, this was a 0 just once, so that is odd, so it's going to cross at that x-intercept. This was a 0 just once, that is odd, so it's going to cross there as well. And this is a 0 just once, that is odd, so it's going to cross all of our x-intercepts. This graph won't be bouncing off any of them. All right. Now the maximum number of turning points is the last thing that we can use to help us make sure we have an accurate graph. And our degree is 3, so the maximum number of turning points is 1 less than that, or 2. All right, so let's plot our points first. We have 0, negative 10, so that's going to be here. We have negative 5/2, which is actually negative 2.5, so that's going to be here. That was an x-intercept. We also had, sorry about that, oh, I'm not sure why I went to that page. I'm not sure why it copied that there. I'm going to have to fix that later. But anyway, back to the graph. Sorry about that, guys. I also had negative 1 and 1. And our end behavior was down to up this time. So since I know these are the only times it's going to cross the x and y axis, I know this is the end on the left. So it's going to come down here. It's going to cross, turn, and cross again. It's got to pick up that y-intercept, and then it's going to cross and go up. So that is the sketch of your graph. The one thing we do not hold you accountable for knowing in Math 171, you'll learn this if you continue on in calculus, but those are those max and min, exactly where it turns and comes back. So that can be a rough graph, but your intercepts and whether they cross or bounce and the end behaviors, that's what we want you to learn for 171.